Good morning or good afternoon or good evening, depending on where you're connecting in from today. Thank you for taking time out of your day to attend an advanced user training session on Storyboard. Of course, today's topic is creating cleaner GUI application code utilizing object-oriented Lua. Before we jump into things, I just want to let you know that today's session will be recorded, which means that if you need to drop off at any point in time, or maybe you have a colleague that you think would benefit from today's session, it will be made available on demand within the next 48 hours. Also, because we are live across the internet, that we'll be taking any questions that you have on today's topics at the end of the session. So please use the Q&A section that you see on your screen to pose any questions that you have to us at any time throughout today's presentation. Also, if you have not followed us, we're active on Twitter, Facebook, and LinkedIn. We often use the hashtag GUI development, or of course, hashtag crank storyboard. We are lucky enough today to have with us Matt Love, who is a senior application architect here at Crank Software, and he will be the main presenter today going through today's topics, which of course will consist of, I'll provide you with just a kind of a brief overview or introduction to Storyboard, just in case maybe you're relatively new. Maybe this is the first time you've heard about Crank Software. Also, then we'll be jumping into object-oriented Lua and talking about what it is and how to create it. And of course, what are the core benefits of utilizing it within embedded GUI application development. And we'll pass along some best practices for implementing it within your storyboard projects. And then, of course, we'll address any questions that you have. So what makes Storyboard unique? Well, it's purpose-built for collaboration around the user experience. So it was really designed specifically to help developers as well as designers kind of create and, more importantly, iterate with ease in the quest for really creating an optimal end user experience on the devices that you are building. It is platform and OS independent, meaning that Storyboard developed GUIs can be easily deployed on different hardware or hardware and OS combinations simply by using the appropriate runtimes that are provided within the project. Also, like I mentioned, there's a distinct separation between the design and the code environment. So the front-end design is decoupled from the back-end logic, enabling you to update and test the app at the same time as, say, other developers or designers without destroying the work or necessitating any extra development effort to be brought into the process. And this is more specific when you take a look at our rapid design and iteration technology. So what it allows you to do is to take the design files that were maybe created within Photoshop or Sketch and import them into the tool, where then those assets become the building blocks to that GUI application. However, at any point in time, if changes need to be made to those assets, they can be made within Sketch or Photoshop, and then those files re-imported back into Storyboard with all the actions or events that were previously established being reattached to the newly changed assets. We also provide you with a unique graphical compare and merge tool, which allows you to remain in control of which changed content you wish to accept and deploy into the GUI application before committing those changes into the final design. So really allowing you to remain, like I said, in control of developing that GUI application. Then, of course, we use hybrid rendering for low footprint and low power apps. So we are the only solution on the market to offer up as hybrid rendering technology that could easily take advantage of a 2D GPU or the 3D GPU GUI, dramatically switching between the technology on demand if it's offered up in the hardware that you are utilizing. Crank Software is also a services company. So if you find yourself in the need for maybe a prototype being developed fast for a proof of concept with your key stakeholders, or maybe your team has an idea but not the time or maybe the in-house expertise to produce it, or maybe you're just looking for ways to optimize the performance of your GUI application that was built using Storyboard. No matter what you're trying to do, our team of Storyboard designers and developers are here to make your embedded project easier. So we can help you from anywhere from starting it to finishing it, planning, implementation, everything in between. Or even, like I said, placing it through rigorous testing to uncover any issues that could impact the performance of your product. Also, if you haven't visited our help center yet, I highly recommend that you do. There you'll find a wide wealth of resources from documentation, knowledge-based articles, as well as a whole series of getting started videos that really kind of dive into the different aspects or the key aspects of using Storyboard. As well as all our past advanced user training sessions can also be found within the Help Center. Plus, we have a community there where if you have any questions that you want to pose to us or maybe other users of Storyboard, it's a great place to do that as well. So with that being said, I'm going to pass things over to Matt, where he is going to take you through the core process of really creating cleaner embedded GUI application code using object-oriented Lua.
Right. Thanks, Scott. Just give me 1 second here. Okay, good. I think that's displaying. All right, so yeah, we are going to talk about object-oriented Lua today and how you can change your more procedural-based Lua code into being more of an object-oriented format. Now, start off. Lua isn't necessarily an object-oriented language. It's a dynamic programming language, but we can kind of utilize some of its features to give a more pseudo class-based system. But kind of let's just start with what is object-oriented programming? Basically a way of writing your code that breaks your program into a bunch of simple and reusable modules. Generally, you're trying to encapsulate, abstract, and inherit code from other modules. Given Lua's dynamic nature, some of that becomes pretty easy, especially having the polymorphic side of it, be able to easily override functions that you store in your Lua tables. But yeah, so to start with, we're generally going to try to take our Lua code. We will write it as each module is a table that contains both the module's data as far as variables, as well as its methods being stored in the table. Beyond that, we can make use of a few features that Lua has to allow it to inherit methods from other modules. And then finally, show you how you can override module functions to kind of give you your polymorphic behavior. So that way you can have, multiple module types work with the same interface. All right, cool. 1 second. Okay. So we're going to take kind of 3 approaches to this. We're first going to structure our code as simple Lua tables. Then we're going to use the meta table that Lua offers to allow us to create objects based off prototypes. And then finally, I'll go into kind of the available meta methods in Lua 5.1. There are a few new ones beyond that, but I won't cover those here. And let's just start off with jumping into some code. Well, first actually I'll go move over here. Yeah, so we'll start with this. We're going to first structure our code just as a simple table with some functions and data stored inside. But we're not going to use the meta table at the moment. Okay. So I'm going to bring up my table sample. Right here, all I have is a single control, and we don't have any Lua code right now. I do have one place I'm going to store my buttons, and each of these controls is going to be a button. So I'm first going to want to create my button object. I'm going to create a new local table. I'm going to want to return my object. Now, since probably going to be wanting more than one button, we're just going to create a new instance of it. So we're going to have a function button.new, and within there, we're going to create a new instance table. Now, this is not terribly useful right now. There's no functions in here. So let's create some functions. We'll create a press and release since we're just dealing with a button. Function since press. And I'm using the colon in order to allow us to prepend a hidden self variable that's going to represent this new table instance. So now we could always use, self.press, and that would exist. Now, not going to do really much with that, but and now we want our release. Okay, so we have our basic button module. It's not really going to do much at this moment. We just want to see if this works. We will store them. We'll store one right now in this button table. That's going to be a global, so we can reference it from Designer. So buttons.button1. Actually, I need to require this first. .new, and actually, just going to start with that. Okay, so now if I run and I press this, right, there's no actions on it yet. So we got to do that next. So there's two ways we can reference this. We could, since we know where it is, we could easily go buttons.button1 press, or we could use the advanced. One thing to note is since we haven't told, we haven't really defined what's being stored in buttons, it can't do the reference, but we can change that right now. Here, just 1 second. Okay. Field, and then we want the path to our components. We want the module type, not that one. And then we want our module name. And then we need to go into our component itself. Module, we got to tell it what the module type is. Now, if we were to go add our action, should be able to pick up our button. And then, oh yes, right. It's not going to be able to find it because we are creating this new object within the new. So that's one thing to keep in mind. This will change in kind of a follow-up example, but for right now, we'll just go with buttons, button 1, press. Save it, run. So now we get our press. And we could do a very similar thing with a release. Button 1, dot release. All right, let's try running that. Cool. So now that we're instantiating our new button, we are hooking up our events to it, and it's not really doing much, mind you. We probably should give it some extra behavior. So let's do that. So since this module represents more than one control, we probably should pass in, the control name. And you know what? Let's also give it a downstate color. Control instance dot down color equals down color. So now we're storing these parameters in the actual table that's being created. And now let's actually give it some behavior. I'm just going to change the color when you do the up and down state. Control. And we'll use the down color that we're storing. And then for the release, we'll just restore that back to green. And we'll do that for all of them. There. Okay. Since we're adding a couple of parameters, we need to actually add them here. And I don't remember what the control name is. Let's get it. Copy path. And we'll make our down color red. Let's go with. Oops. Save. All right, let's try that now. All right, great. We have one button. Let's say we wanted to make more. Just want to get the order right. Okay, got my 4 buttons. Now we need to create 4 new buttons, or 3 new buttons, I should say. And we'll just change the down color a little bit. Now, we need to target the right controls, obviously. So we just need to change what module we're targeting for our press and release functions. Just making sure, oh, made a mistake here. Okay, should be all of them. Let's test that. Oh, see, I made a mistake. Forgot to change that. Try that again. There. So now the fact that we have the same module representing all of these controls, we can customize them just based on the parameters we're passing into our new. This is fine for a really simple module, but if you're going to have lots of functions on it, this new function would get very messy pretty quickly. So to help with that, we can actually create these new instances based on a module prototype by using the metatable. And essentially, let's switch back to my slides. Essentially, the metatable is used to modify the way a table behaves. What you do is you call set metatable, you pass it a table representing your metatable with a bunch of predefined meta methods. And then depending on the meta method you've implemented, you can change the behavior of your table. You can also retrieve the meta table from an existing table. That might be useful if you wanted to add something to override an existing table's behavior. Oh, nope, that's not what I wanted. All right, so this is kind of the list of available meta methods for Lua 5.1. The one we're really concerned about, to be honest, is index. It's what's going to provide us our inheritance from our prototype. And it gets invoked when you're indexing a key on a table and it doesn't exist in the actual table instance. So then it'll automatically look in the meta table, it'll look for index, and it'll look up the key from that function or table that you provide. New index is when you assign a value to a key that doesn't exist. Mode controls kind of the weak table references, so you can customize your table to get garbage collected depending on the mode you pass. Call allows you to treat your table as a function, which I will show a little bit later. Metatable, you can override what gets returned with get metatable. So if you want to hide your actual metatable for your module, you can implement that and it'll do it. And then toString just overrides the toString behavior. Nothing too complicated there, but the ones we're going to care about here is index and call eventually for one sample. So we're going to switch back here. So let's take our button and base on a prototype instead. So we'll get rid of those functions. We're going to make them part of our button prototype. These will copy. Function. We'll put that as part of our init. method. Actually, I'm going to move this up here. I'm going to have this take a variable number of arguments. I like it. This looks cleaner. We're going to use set metatable. We're going to want to set the metatable on our new instance. And the only meta method we care about is index, and we can pass it button. And there's two ways you can do this. You could have a function, or you could have a table. So Lua has some convenience behavior. If you pass it a table, it'll know to look for index. It'll know to look in that table for the missing key. So yeah. So right here, we've instantiated our new instance. We've kind of assigned it as this prototype of a button. And now we have access to any of these functions. So just to test that, let's use init. And we'll just pass it whatever parameters we get, and we're done. Okay, so this should work exactly the same. There should be no difference. Oh, there's a difference. What did I do? Oh, what did I do here? Yes. Forgot self. All right, let's try that now. See if this goes better. Got a problem on my release. Did I do the same thing? Interesting. Okay, well, I'm unsure why that's not working right now. There's got to be a reason, and I'm not seeing it. Anyway, all right, let's move on kind of from this sample to kind of a more advanced version. This is essentially the same sample. The differences here is I created a second module called toggle. All right, so I created this toggle sample that essentially first instantiates the button, and then I override the press event and the release event so I can get some toggle behavior. I'm just going to shut down my old versions running. Let's see if this one works a bit better. Okay, so this one's working better. So as you can see, I changed the second one to be more of a toggle, and then the other ones are still the same component as before, the button. One other thing we can do, and what I talked about with the call, is we could take a lot of this functionality and bake this into another module. So if we wanted to have a base class for each of these, we could create, say, this class implementation. And all this does is allow us to create a new type of prototype based on a base class. And where we're using the call is for this class module. So we can call class as a function, give it a base class, and then it'll return to us our new formatted module prototype. And we can get rid of, since it has new inside it, it's got new as a init, it can get us the current prototype class and can also get us the base class for that, as well as it can tell us whether we're an instance of another class. So kind of similar to an object-oriented language like Java, where you can have, your subclass be an instance of a base class. The same thing could happen here. But given that Lua isn't object-oriented generally, this is just us replicating that behavior. So now if we wanted to do the same thing here, hold on one second. Want to make sure I don't make a mistake this time and then get messed up. Okay. So we need our class. Now, instead of a empty table, we're going to call class. We don't have a base class for button because it is our base class for our two types. Now we do not need new any longer because it's implemented in class. So we can just delete this. We'll, oh, not what I want to do. We'll keep around our init because it's overriding what class has given us, and we're keeping our button and our press. Right? So now if I were to run this one, everything should work still. No difference. Now we could do the same thing for toggle. Actually, and our base class for this is going to be a button. We can get rid of new again because we no longer need it. We will need an init though. So function toggle init. And we want to make sure get our superclass and call init itself in there. And then hold on one second. Actually, don't need that. Self.pressed, make that false just to initialize it. I'm just going to double check. Okay, everything should be good now. Let's see if this runs. Yep, everything's still working. So now we're creating our prototype for our toggle via our class utility. And kind of the neat part about this now is we can start doing things like checking types. So if we wanted to say buttons, button one instance of button, actually, just to speed us along here, I'm just gonna copy some stuff. Okay, so we got a couple of if statements here. First one, we're checking to see if button one's an instance of a button. It is. Second one, we're gonna see if button one is an instance of a toggle. This should not appear because it's not a toggle. Then we're gonna check, is button two an instance of the class of button one? And it should, because button is the base class for toggle, which is what button two is. And then the last one we're gonna check, is button one an instance of a toggle, because that's what the class for button two is. This should not appear because that won't be true. And if we run it, so we get button one is button one is not a toggle, and then button two has the same prototype as button one. So now we know our instance of function works. So we can check, how do our instantiated types compare to one another? And yeah, kind of that's the basics of how to write Lua in an object-oriented way. Sorry about the technical difficulties when I was doing that. I'm not exactly sure what happened, but anyway, yeah, let's just move on. So I just want to quickly kind of discuss some of the benefits. Well, start with allows you to reuse your code. as we saw with the toggle and button, we were able to reuse a lot of our initialization code. Yeah, we overrided all of our functions, but you can easily have functions that aren't being overridden from your base class. That does give you some flexibility when you, instead of modifying your, say, when you have a new feature, instead of modifying your original class, you can easily extend it and then add support to your new class type. For maintenance perspectives, it's really useful since you can encapsulate the behavior of a certain part of your software into a specific object. Assuming you're not using global states, that's where you can get in trouble. And that also helps with some of your troubleshooting. If you name things correctly, it becomes very obvious where the functionality exists in the application. That leads us into some best practices. Writing Lua in an object-oriented fashion is not any different than any other object-oriented language. You should follow the same principles. You should ensure that your module only has a single responsibility. So it's, you don't have multiple modules responsible for the same thing. You should ensure that if you are going to extend the functionality of your application, you're not just modifying an existing module, you should extend it. Obviously, you want to have reusable code, so don't repeat yourself. If you can encapsulate any common code into a module that's either used by multiple parts of the application or inherited by multiple modules, you obviously need to use you have to use meaningful names. That helps you with your maintenance later on. You should avoid global states as much as possible. That just keeps any sort of pollution from happening between your different modules. I have seen instances where someone, if I'm switching back to code, in their module, they'll put a local variable up here, like down color. And then that's where they store it. And every time they instantiate a new instance, they're overriding this and affecting the behavior of all the modules. So this is an example of global state, but you could also have global state as your entire application. So, and the kind of final thing is, if you want to make use of the advanced Lua, where is it? What do we call it? Yeah, this advanced Lua thing, you need to ensure you're naming things correctly. But in order for anything to show up under there, you need to document both your modules and anywhere you're storing an instance of it to tell it what it is. Oh, maybe that's the reason actually. Anyway, because this is what provides the link to Designer to know where to locate functions and everything. It'll first look here. This is where it provides each of these instances. I told it what the field should be, and then it'll look up the right module. For instance, this one, it'll know this is a button module, and here's the available methods on it. I'm not sure why it's not working for this sample right now. It's something I'll have to look into. But yeah, that's it. So that's all I have right now. And yeah, thanks.
Perfect. Thank you very much, Matt. So just to kind of wrap things up before we jump into your questions, like I said before, if you have not visited our help center, that is full of additional resources, including getting started videos, knowledge base articles, a place where you can request help, as well as you can check out all our past training sessions. So we've been running these advanced user training sessions for the last year now. really kind of diving into deeper dives into different aspects of Storyboard. So there's about 12 to 13 other ones that you can get your hands on, and it's all located within the Help Center. As well as, if you have not learned about Storyboard 7.0 or heard that we actually recently released Storyboard 7.0, we have our launch webinar that is accessible via our webinar page, and you can go and you can learn about all the great enhancements that were made to Storyboard with our current release. So let's take this opportunity now to jump into your questions. So like I said, if you haven't had a chance, now's your chance using the Q&A portion of your web window to pose any questions that you have. So let me just kind of take a look to see what we currently have available. So Matt, can object members or methods be made private?
That's a good question. So you can definitely make methods private to your module. What you would do there is essentially, instead of storing them within the module instance, like the table that's representing your module instance, you would just have it as a local function within that file. So as I said before, trying to avoid, global states for data, having functions that are accessible to any instance of the module kind of like lets you hide that away. Now, as far as private data, it's a bit more complicated because Lua doesn't exactly have a method to do that. You can disguise things, or you can use a naming convention to differentiate between private and public data. It's probably the safest way to go, because the reality is anyone can run a debugger and investigate your module and find where the data is stored. I've seen a few tricks that people have done to make it more difficult, but it's not foolproof. I hope that answered that question.
Perfect, that's a great answer. Another one for you, how can the meta methods be bypassed?
So there's a couple of functions to do that. You want to use, I'm trying to remember the name of it. I think it's raw get will bypass, say, the index meta method, and then raw set, I think. Maybe it's get raw and set raw, I can't remember that. Does the opposite. It'll bypass using the new index.
Perfect. Do you have this sample somewhere or a blog post we can reference this? I've used object-oriented before, and setting up is usually the hard part. Using it later is very convenient.
Do we have a blog post about it? I believe we do, actually. Well, it might not have been a blog post. We definitely have an article in our Help Center that demonstrates how to use the meta table and how to write your Lua code in an object-oriented manner.
And so what we can do is during the kind of the follow-up email that provides you the access to the link, we'll search that out and we'll make sure that that's referenced in that email as well. However, maybe some of the sample code that was used today might make maybe a great kind of knowledge base article that can be referenced moving forward as well. So we'll look into that for you as well.
Yeah, probably the second sample would be an interesting knowledge base article, because I don't believe we have anything that that quite replicates the behavior of, say, an object-oriented language like that. So.
Perfect. Another one is, why isn't my module found in the advanced section of the Lua action dropdown?
So that well, there's a couple of reasons why. One, the documentation in your Lua code isn't quite correct, and designers not able to parse it and kind of create that link. The other thing it could be is there's no global entry point. So you need, in order for kind of designer to find whatever module you're referencing it, you have to reference it from a global object. It's why in my sample I had a global table called buttons, and that was my entry point into the rest of the world. From there, I can index one of the entries for the buttons, and then I can call a function on it. So those are the kind of the two places to look. My guess would be veering more towards the documentation, because even, you know, in my sample, my documentation wasn't quite right, and it didn't do it. It couldn't find the functions for the modules. So.
Nope, fair enough. Perfect. That seems to be the last question. So if nobody has any more questions, I just want to thank everybody for taking time out of your busy day to come learn a little bit more about Storyboard, and in particular, leveraging the different ways that Lua could be utilized when developing your embedded GUI applications for your hardware. And thank you very much, and enjoy the rest of your day. Thanks.
Okay, thanks.